Hey everyone, welcome to Voltamin. Today we've got two supercapacitors, each rated at 500 farads with a maximum voltage of 2.7 volts. And both of them are already fully charged to 2.5 volts. They're packed with energy and ready for action. These are not your ordinary capacitors. Supercapacitors can store a lot more energy compared to regular ones you find in everyday electronics. Let's start by connecting these two capacitors in series. When capacitors are connected in series, the total voltage increases, but the total capacitance decreases. Here's how it works. Total voltage is equal to voltage 1 plus voltage 2. So our new max voltage becomes around 5 volts. But the capacitance is reduced. The formula is C equals C1 times C2 over C1 plus C2. Since both are 500 farads, the total capacitance becomes just 250 farads. If both are equal, we can simply say total capacitance C is equal C1 over 2, which is equal to C2 over 2, which is equal to 250 farads. Let's check the voltage across the entire series connection and also measure the voltage across each individual capacitor. Sometimes the voltage splits evenly, but in practice, small differences in internal resistance or leakage can make the voltages slightly different. Next, we'll switch to a parallel connection. In parallel, the total voltage stays the same, 2.5 volts, but the capacitance adds up. Total capacitance is equal to C1 plus C2, which is 1,000 farads. That's a lot of stored energy at low voltage. Perfect for experiments like this. Let's check the voltage again across both capacitors. They should both have exactly the same voltage in parallel. The conclusion is that parallel connection provides more capacitance, which is equal to more current capacity or higher amperage at the same voltage. However, in series it gives less capacitance, which supplies less current capacity or lower amperage but higher voltage. Now for the fun part, I'm going to connect these two fully charged capacitors to this DC motor. This motor is bigger and more powerful than the small ones we tested in a previous video. If you remember, in that video, linked below, just one of these capacitors ran 4 small DC motors for almost 15 minutes. Now with two capacitors in parallel, but running only one bigger motor, how long do you think it will last? Let me know your guess in the comments. If you enjoyed this fun supercapacitor experiment, make sure to like, subscribe, and join the Voltamin community for more cool electronics experiments. See you in the next one. Let me know if you want me to make it even more energetic or casual.